this is Sung, and I'm the Principal and Director of Sky Academy, and in this episode we're going to start a brand new topic. It's the topic of basic algebra. Now, let me just stop for a second and say that algebra is something that you will have done from year 7 all the way through to year 10, and so most of this stuff will be stuff that you've done before and are quite familiar with. Having said that, what I want to do in this chapter is focus specifically on the algebra that you will need, almost like a prerequisite to advanced maths. And rather than going through the whole of the year 7 to 10 maths, what I do want to do is touch on the points where most students who come into 2-unit advanced maths have kind of weaknesses, so that I can really pinpoint those and say this is what you need to focus on from my observation from teaching students in the past, as well as the parts of algebra that you really need to be strong in order to continue to do well for the rest of the course. Alright, so what I will be doing here is focusing on those parts of algebra that you will need to focus on in order to continue to do well in the 2-unit course. So one of the areas where most people have and continue to have struggles with algebra is in collecting like terms. So let me focus on collecting like terms with you. Alright, and we'll start with some simple examples and just kind of go through it with you in such a way that we kind of get to the stage where we're really robust with our algebra skills, especially when it comes to collecting like terms. So let's have a look at this question here. You get 3x plus 5 plus 7x plus 10. Alright? So you can't add constants with pronumerals. You can't do that. You got to collect pronumerals with pronumerals, constants with constants. And not only do you have to collect constants with constants and pronumerals with pronumerals, but you've got to make sure that the pronumerals end with the right pronumeral combinations. So you got x here and you got x here. So you got 3 lots of x's and 7 lots of x's here. You can collect, these two are called like terms, you can collect, right? Now a constant, I've been throwing that word around, but what a constant actually is when it doesn't have a pronumeral after it. A pronumeral being instead of a numeral, okay? So a number that's used instead of a numeral, in other words, a letter, okay? So if it doesn't have a letter, then it's called a constant, all right? So you got this constant here and this constant here, 5 and 10 you can add together. Now let me show you how they work. 3x and 7x go together, right? So I'm going to put a red circle around 3x, and I'm going to put a red circle around 7x, but with that 7x comes a sign. You need a sign to combine it with the 3x, right? And the sign is, the only sign that's there is plus, right? So it's definitely plus, but the question is which plus? Is it this plus here or is it this plus here that combines with the 3x? It's always the sign in front of the pronumeral expression. So if 7x is the pronumeral expression, it's always the sign in front of it, alright? So those two combine together, and 5 and 10 can combine together, but this plus belongs to the 5, and this plus belongs to the 10. Does that make sense? So if we were to rearrange that, what you would have is, and let me grab my black pen, 3x plus 7x plus 5 plus 10. Does that make sense? So what we've done is we've moved this over here, this over here, this over here, and this over there, right? Which means that what we can do is 3x plus 7x, right? So if you had X for X-ray scans. If you had 3 X-ray scans and you added 7 X-ray scans, alright, you'd have how many? You'd have 10 of them. 10x, 5 plus 10 is 15, so plus 15, and that would be your answer. Does that make sense? Alright. Now you're doing the same thing here, but there's an added complexity. With this question here, what you've got, I've done this question here, so let me just put that line there. With this question here, you've got an added complexity. The added complexity is that you've all of a sudden got minus signs, right? Not only do you have minus signs, but instead of a pronumeral term and a constant term, you have two pronumeral type terms and two. So you've got one pronumeral type term in the A, and you've got another pronumeral type term in the B, right? So what you've got, and if I circle it, you've got the 4A and the minus A going together, because remember it's always the sign in front of that. And then you also got the plus B and the minus 4B going together. So when you combine that, it becomes 4A minus A and plus B minus 4B. Alright, so let's see what results when we do that. 4A minus A is not 4. The A's don't cancel out. That's not how you do it, okay? When you're minusing, it's almost like you have 4A for apple, 4 apples minus 1 apple, right? Which is 3 apples. 1 banana minus 4 bananas is negative 3 bananas, right? So you just write negative 3 or minus 3 bananas. And that's the answer for that particular question. The next question has another layer of added complexity, namely xy, xy, yx, right? So in this pronumeral expression, you've got two pronumerals being multiplied together. Now, is an xy and xy a like term? Yes. So if you've got 3 xy's and you add another 2 xy's, it ends up being 5 xy, right? But what do you do with this yx? Well, yx, is that the same? Is that a like term to xy? And the answer might surprise you. The answer is yes, indeed it is. And I'll tell you why. Because in between this x and this y, you have a multiplication sign. X times y. So it's x times y. Okay? Now, is x times y the same as y times x? Let's have a think about it. What's 3 times 4? Well, it's 12, right? And is 12 also the same as 4 times 3? So because 3 times 4 is the same as 4 times 3, xy is the same as yx. Alright? So you can actually say that these are like terms. So when you combine them, you've got 3xy plus 2xy minus 1yx. And if there's no number in front of it, it's because there's only one of them. Okay? So there's an invisible one there. Okay? So you got 3xy plus 2xy, which is 5, minus 1, which is 4. Now the answer will be 4xy, right? Or, what's the other answer it could be? 4yx. Alright? So the answer is either one or the other of those. You just need to write one of them. You don't have to write both answers. You can just write one of them. That's sufficient. But usually what we do is when we write our answer, when you've got a combination, when you've got a combination like this, is that you do it so that you write your pronumeral combination in such a way that it's in alphabetical order. Okay, so x comes before y. So usually, by convention, that would be the way that you would write it. Although this is just as valid. Okay. Now, I'm not going to go through indices with you because that's a whole nother topic which we'll go through later. But it's also, indices is also something you will have been familiar with if you have done the the years 7 to 10 maths course with algebra. Okay, so let me just have a look at this question here because this one will be quite interesting. Right, in this question here, you've got 3p squared q minus 5pq minus 2pq squared. Now, in order for the terms to be like, the powers have to be, not only do the combination of letters have to be the same, but the powers also have to be the same as well. So is p squared q a like term to pq? No, because p squared q is almost like it's p, q. So the 2 means you got 2 p's multiplied together and a q. And that is not a like term with pq. Nor is either of these two the same as, or a like term to, pq squared, which is the same as pqq. See how you don't quite have the same combination of letters? Yeah. Given that you don't have the same combination of letters, you can't say that they're like terms. And if they're not like terms, you can't collect them the same way. So the answer for this question, surprisingly enough, is just 3p squared q minus 5pq minus 2pq squared. It just stays the way it is. Okay? And that is the answer for that particular question. Okay? Alright. Now, on the other side, alright, we've got another question. These are the questions that you should be able to do now. Okay, so we'll kind of do them a little bit faster than the way that we did them before. Alright, a squared and 5a squared. A squared is like AA. 5AA is like 5AA minus 3a minus 5a. Right? These two are like. These two are like. Alright? So the way we do this is a squared plus 5a squared is 6a squared minus 3 minus 5 is minus 8a. Okay? Good. Now, 12mn and 6mn, they're like. So that and that go together. 12mn minus 6mn plus 3m minus m. So those two are like, which means that the answer will be 12 minus 6, which is 6mn, plus 3 minus m is plus 2m. This question here, a squared b, a b squared, they're not like, because the square is above the a here and above the b there. But this one, a squared b, is the same combination as this, a squared b and ba squared, they're the same. So these two are like terms. And the third one is unlike. This one's unlike. So you got 3 plus 2, which is 5a squared b minus 3ab squared. And that's your answer for that one. Okay? And then your last one here, ABC is the same combination as BCA but in a different order, which is also the same combination as CBA but in a different order as well. So the order doesn't matter as long as you've got the right combination. 3 plus 5 of them is 8 of them, minus 2 of them is 6 of them. So you got 6 lots of A, B, C, or you could just as easily write 6 BCA or 6 CBA, right? You don't have to write all 3 answers, you can just write one of them and that is totally fine. Hopefully, by me going through all these questions, you will have an idea of how collecting like terms work. What you need to do now is go away and make sure you practice it, and not until you can get them right, but until you can't get them wrong. Okay, so you really need to be really fluid with this sort of work, and when you are, then this course will become a whole lot more manageable for you. Alright, so enjoy going through those questions, and I will see you on the next episode. Thank you.